Hello, beautiful people. Today we're going to be doing 5.4 factoring and solving polynomials. That should be an S there. Let's just fix it. Factoring and solving polynomials. So we've already done some stuff with factoring. We're still going to use the box method, and we're still going to use some special patterns. The only difference now is that instead of just usually dealing with a variable squared, you're going to have a higher exponent to deal with instead. We can do it. So looking at number one, factor the polynomial completely. Looking at 30c squared minus 54c squared, the first thing I'm going to do on my checklist is to see, do they have anything in common? And for me, I'm looking at the 30 and the 54, and I know that 6 can go into both of them. And then I'm looking at the variable, and I see that this has c cubed and this has c squared. So the maximum number of c's I can take out of both of them would be c squared. I'm going to put my leftovers in parentheses. So what times 6 gives me 30? That would be 5. And c squared times c would give me c cubed. Pretty much I'm just subtracting the exponents. 3 minus 2 leaves me with c to the first power, except we don't write the first power there. It's just not a good look. Minus 6 goes into 54 9 times, and there aren't any c's left because I took all of them out. Now the question is, can I factor this anymore? Not so much, because it is linear. The exponent here is 1, so there's nothing else that I can do with that. You can box that up and make it your final answer. Looking at number 2, I'm looking at all 3 of these terms, and I'm noticing that they all have an m in common. So I'm going to factor that out first. And left over I have m squared minus 6m minus 72. Not really so much new. We are kind of trying to ease into the newer material. So from here, if I were you, what I would love for you to do right now is just pause it if you'd like to. Go ahead. Otherwise, you could watch me factor this. I need two numbers that multiply to give me negative 72m squared, and that add to give me negative 6m. Remembering that for my box, my first term goes in the first box, and my last term will always go into the last box. So two numbers that multiply to give me negative 72 and add to give me negative 6 would be negative 12m and 6m. From here, now that I've done that wonderful part, you're going to put these in the box, and then you're going to factor. So this is m they have in common. These two have negative 12 in common. Looking from left to right, we have an m, and here they have a 6. So this factored completely would be m, don't forget this because we factored it out in the beginning, times m minus 12 times m plus 6. And there you are for that problem. Okay, moving on. So special patterns, some of us learned them in the last section or last chapter. Some of us have another shot. Now instead of the difference of two squares or the sum and difference thing, now we're going to do the sum of two cubes and the difference of two cubes. So they're going to follow this pattern. So anytime you're adding and you have a perfect cube and a perfect cube, you can use this pattern. Same thing if you have the subtraction one instead. So cubes is just a number cubed. So like 1 cubed is 1 perfect cube. 2 cubed, that's 2 times 2 times 2 is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125, ... So I'm looking at number 3, and my first instinct is going to be to try to write these as perfect cubes. So 125 is 5 cubed plus x cubed. This is great because now I'm going to follow this pattern that we have here. So this will be equal to, well, my a is 5 and my b, so I'm going to write that for us. A is 5, b is x. Plug directly into here. So I'm going to have 5 plus x, plugging right in, is 5 squared minus 5 times x plus 5 squared. From here you'll simplify and get 5 plus x times 25 minus 5x plus 25. There you go. That's your sum of two cubes. The sum of two cubes. For here, looking at these two, this is not a cube. But my checklist, I want to see if they have anything in common. So I'm looking at 64 and 27, not a number I can think of other than 1, so no one cares. But a to the fourth and a both have an a in common, so I'm going to factor that out. And I have 64a cubed minus 27. From here, I'd like for you to use this pattern to simplify it. So you know that your a is, well, what? 4a cubed gives you this number minus 3 cubed. Just giving you a little bit more of a hint, times a. So try this now using 4a as your a and 3 as your b. Go ahead and press pause and then check back with me when you're... All right, looks good to me. Check. What people like about this is there's not the 2ab that we had in the previous chapter, in the previous section. So because they just have to multiply these and make sure that they change the sign, people tend to do pretty well with this. So I'm going to box that, let you check it. And if you are struggling with this, press pause, check in with a neighbor, and make sure that you're okay. Onward. Factor by grouping, probably my favorite type of factoring. Grouping symbols, the most popular one that we will ever see is our parentheses. So what we're going to do to factor by grouping is group. We're going to group the first two terms together and the last two terms together. So I'm looking at this first set right here. What do they both have in common? Well, this is x cubed and this is minus 2x squared. They don't have a number, but they both have an x squared in common. So I'm going to factor that out. Then my leftovers I will put into parentheses, and my leftovers here are x minus 2. Then I'm going to look at the next set of numbers that we have, and what do they both have in common? Well, this is negative 9 and this is 18, so I'm going to factor out a negative number, and then I'm going to put my leftovers in parentheses. So if I divide this by negative 9, I get x. 18 divided by negative 9, I get negative 2, because a negative times a negative is a 2. And one thing I was trying to do, and I kind of fell off right there, my leftovers in parentheses are x minus 2. Like the color coding, I hope you do. Take a little extra time for that, because I'm looking now at both of these terms, and they both have an x minus 2 in common. I'm still factoring. I'm still in my factor zone. So since they both have an x minus 2 in common, I'm going to factor that out now. And then I will put my leftovers in parentheses. So leftover from the first pair, once I factor this out, is x squared. Leftover from here is minus 9. Now, most cases, if this was algebra 1, we would be done right now. But we're not. This x minus 2 is great. Love it. Nothing I could do with it. This is a special product also. Remember a squared minus b squared? The one that I told you, it's going to keep coming back and coming back and coming back and coming back and coming back. Well, here it is again. We're going to use that now. Perfect squares. So the square root of x is x. So it says plus b. So plus what squared gives me 9 is 3. And then x minus 3. Remember, it's the same thing except one is plus and one is minus. Beautiful. Next one, factor by grouping again. Probably a little bit less colors. Try it now on your own if you don't mind, and then you can press pause when you are ready. But I'm going to get y squared minus 3 minus 4 times y squared minus 3. Should be where if you're factoring by grouping, you get the same thing here. So this is y squared minus 3 that they both have in common. Leftovers is x squared minus 4. What a coincidence. We get to use this special pattern one more time today. So the y squared minus 3 does not fit the special pattern though, because this is not a perfect square. So you leave it. Don't make up two numbers. Don't put square root 3, square root 3. Don't do it. Don't do it. But you will factor this because this is a perfect square and this is a perfect square. So you get x plus 2 and x minus 2. Put a box and you are done with that one. Factoring by grouping. Most people love it. Now, factoring, we're going to do these similar to what you've done before. So I'm looking at this and I have x squared plus 4x minus 21. They don't have anything in common. So I could either freak out or I can just use the basics that I learned about using a box. So here's my box method. And there's only 3 terms here, so I'm pretty positive that I can use it. I'm going to put my first term in the first box and my last term in the last box. Then you're going to do the same things we've done before. So I need something that multiplies to give me negative 21x to the 4th. and that will add to give me the middle term here, 4x squared. Two numbers that I can come up with are 7x and negative 3x squared, though. So this is going to be 7x squared and negative 3x squared. Factoring this out now, they both have an x squared in common. These two have a 7. Looking from left to right, we have an x squared again, and these have a negative 3. So this in factored form will be x squared plus 7 times x squared minus 3. Here, oh, you can put a box, make it official. For this next one, this is special to me. If you were listening for the doot-doos, you would know that this is a special product because this is a perfect square and this is a perfect square. So I'm going to go back to the sum and difference pattern that we just used before. What squared gives me 25? Well, 5. What squared gives you x to the 4th? X squared. What squared gives me 36? 6. And then remember, you're going to have the same thing, except now the second parenthesis is negative, or subtraction rather. Put a box around yours. I know I didn't. You'll be okay. For this one, I'm looking at them and I'm kind of worried because this is b cubed. Things aren't looking right. So I'm thinking, let's see what they all have in common. They all do not have an a in common, but they do all have a b. How many b's do they have in common? Well, this has squared, third, and to the 4th. So the maximum I can take out is the squared. Left over is a squared minus 8ab plus 16b squared. Special pattern alert. This is a squared plus, well, actually this one is minus 2ab plus b squared is equal to a minus b squared. Use this to factor this equation. Press pause now and then press unpause when you're done. Did you press pause? If you did, great. I love you all the more. If you did not, I love you a little bit less. Still love you though. Okay, onward to our last and final example. It says to solve by factoring. So I'm going to look at these two numbers, and because this list looks like a mess, I'm going to first see what they have in common. So they both have a 2 and they both have a y. Left over is y to the 4th minus 9 is equal to 0. Y to the 4th I still like because it's a perfect square. It's just y squared. So this is going to be 2y times y squared minus 3 times, plus 3 does not matter really. I just did that because I'm like that. Y squared minus 3 equals 0. So now, as you've done before, set them each equal to 0 and solve. So this is going to be 2y equals 0, y squared minus 3 equals 0, y squared minus 3 equals 0. This one, loving it. Y equals 0. Not a problem. Add 3, y squared equals 3. Not done, because now we're going to take the square root of both sides, and I get y is equal to positive or negative radical 3. Same thing over here. I'm going to add 3. Something's wrong. Yeah. One of these has to be plus. Apparently I just solved this one instead of this one, so I'm going to make this plus instead. You're fine. Don't worry. Don't stress. It's fine. And so I get y squared is equal to negative 3 radical. Y is equal to positive and negative. Well, it's negative in the square root, so I'm going to make this I in front. Now I'm okay. So if I was going to write this on an answer column, I would just write y is equal to 0, positive and negative radical 3, positive and negative I radical 3. Those are all 1, 2, 3, 4, 5, 6 of my answers. I don't know. I'm just kidding. 1, 2, 3, 4, 5 of my answers. Hint for next time, because it's to the 5th power, I'm going to have 5 answers. Okay, thank you so much for joining me. Appreciate your thoughts and your prayers for myself and my family. And I will see you all after break. Thank you so much. Bye-bye.